Hey guys, so my name is Marek Drapala and I'm going to be covering section 7.3, which consists of finding the volume using the shell method. So, starting off pretty much with the shell method, the way it works is you kind of are, well, what you're doing is you're finding the volume of an object, and what you do is you kind of want to peel the layers off of the shape, and then if you were to peel those layers off and place it flat on a table, you find the area of that rectangle which is formed. So here, if you see, if you were to take like three pieces of paper, right, that's your shape right there, like that. And if you were to peel back these layers, you have three layers, and then this is what you use to find your volume. So a written example we have here is, one second, if we're gonna draw this, we have a cylinder here, like that, and like this. Here you have your radius, R. Here's your point of rotation. Here's your Rx. And here, of course, you have your H. And see here, if you were to take and almost like peel this, like probably like an onion, let's say, you would have one layer which would end up being one long piece like this rectangle. Oh, I'm sorry. It'd be one rectangle like this. Let's say you draw it in your plane like this. You then have your 2 pi r and your h here. So this is the same shape as this, just you peeled it out and you placed it flat like this piece of paper on the floor. And then what you use, which is provided, is 2 pi r times h times the change in y, which is your thickness. And what we do is, here we add together each peel slash layer to get the volume of the solid, and we're going to be using integration using this. So here you have your equation for your x-axis. So y dy, that's for your x-axis. And this is going to be important later once I explain why you even have one. And then you have 2 pi r x times x dx for your y-axis. So the reason you need this is because you need to change the orientation. So currently right now you have this in landscape, which is horizontal, but what you need it is in vertical. So right now, if I'll draw you an example. Right now we're in this position, but what we need to do is get here, like this. So to do that, you have your equations right here. And this is what your final product, per se, would look like. You have your radius here. See, and you have it in vertical. You have it vertically positioned. You have your longest side here. And you have your h, which is equal to y, right here. So that's kind of the basis and the premises of this. You start with your shape, which right now we have a cylinder. And if you were to kind of, like I said in the pieces of paper, if you were to, like, let's say you peel it off, you would then have a flat piece of paper like this. And that's where you want to start calculating. And this is the basis you go off of. And then the thickness is your layers, which is the change in y. And then you want to make sure you go from landscape to a vertical mode, and you use that using these two equations. So if we do a practice problem here, we have this. We have y equals x minus x squared. Okay. So what we do is, first, the best thing to do is graph. So when you see an x squared, we think of kind of like a parabola. But since it's negative, you want it upside down. So if you're 1 here, you have your 0 here. So you want to draw a shape, something like this. So right here, you got your radius, it goes Rx, and you have your p of x. P of x. So to start off, we start off with the graph and we have a radius. So we're gonna solve this using integration, and we have to remember we're rotating this on the y-axis. So what we want to do is use our formula that we have here for the y-axis and use the information we have. So what we would get is 2 pi integral x minus x squared times x to the dx. We always want to make sure we have the dx. And it would be 1 to the 0, because you have your 1 here, and you have your 0 there. And that's it. That's how you solve one of these problems. Thank you.